Good day, ladies and gentlemen, personalities. Today we are going to speak about linear patterns, or other people call it arithmetic sequence. It's linear patterns, or other people call it arithmetic sequence. Ladies and gentlemen, personalities, I want to state this both categorically and emphatically that these two things are exactly the same. Alright, it's just the different words. In other books you will find linear patterns, in other books you will find arithmetic sequence, but whatever that they mean, or whatever they are referring to when they are talking about these two things, they are referring to one and the same thing. Alright, it's like me, my name is Mqondisi, and then my other name is Elfas. So when you say Elfas, you're talking about me. When you're talking about Mqondisi, you're talking about me. Alright, so I will also be using these words interchangeably. Right? So what we're going to be discussing today is how to look at questions in this kind of a topic. But more than that, what is arithmetic sequence, or what is a linear pattern, and how does it work? So at the end of this session, you should know those two. Right? Alright, now ladies and gentlemen, there are two things here. Okay, there is a pattern, or it's a sequence. Now before we can actually find out what a linear pattern is, we should ask ourselves a very quick question. Before we even get what a linear pattern is, what is a pattern? Okay, or what is a sequence? Right, now ladies and gentlemen, personalities, if you have a list of numbers that follows a certain pattern, therefore you then say those numbers are a pattern. Alright, you've got numbers following each other and then they follow a certain pattern. Therefore you can call that a pattern, or you can call it a sequence. It's just a list that follows a certain trajectory. Alright, that makes sense. So for example, in this particular case, you've got 3 followed by 5, followed by 7, and followed by what? And followed by 9. Okay, so we said this is a list. Now because it is a list, so you will have a first term, which is in this particular case 3. Right? So we refer to the first term as what? As T1, which means term 1. Does that make sense? All right, and then the second term we refer to it as T2. T2 simply means it's the second term. Okay, and then the third term is what? Is T3, and then what is the fourth term? Pause this video and find the fourth term for yourself. There we go. The fourth term is what? Is T4. Okay. So we've got T1 followed by T2 followed by T3 followed by T4. Now from looking at these, ladies and gentlemen, personalities, it then turns out that you can still find T5 somewhere, and T6 and T7, and so on and so forth. All right. Now, you've got a list of this number. They are following a certain pattern. Now, the question is, what is that pattern? Okay. Now, let's look. Now, how do we then find that pattern? Okay, we'll look at the first two numbers. Okay, first two numbers. Okay, the difference between these two numbers is what? What is the difference between 5 and 3? It's actually 2. Oh, okay. Let me keep that in my mind, and then let me go to the second number and the third number. What is the difference between these two numbers? Okay, I'm finding something interesting. It's also 2. Okay, let me go to the third and the fourth. Okay. So, what is the difference between these two numbers? The difference between these two numbers is what? It is 2 as well. So all of these terms, the difference between those two numbers is 2. All right. So if I were to be asked to find the next term, which is T5, what will be T5? Okay, because I've noticed that the difference between these two numbers, if I take any two numbers, the difference between them, or two numbers that are following each other, that is very important, ladies and gentlemen, personalities. If I take two numbers that are following each other, not just any two numbers, I find out that the difference between them is 2. So what does that tells me? It tells me that if I want the next term, so if I have 2, I just add 2, and then I get what? 5. And then from 5, I just add 2, and then what do I get? I get 7. Okay, so you just say plus 2 to get this one, and then you say plus 2 to get the next one, and then here you also say plus 2. Okay, so if I wanted T5, how could I find T5? I will also add 2, because all of these other numbers were obtained through adding 2. Okay, so if we say 9 plus 2, what do you get? 9 plus 2 is nothing other than 11. So I've got 11. Okay. Aha. Now let's say I'm also looking for T6. How can I find T6? I do the same thing, T6. I do the same thing. I just do what? I just add 2. Okay. So I added 2 here. I added 2 here. And then here I will also add 2. And then what do I get? I get 11 plus 2 is 13. Okay. And then 11 plus 2 again. What do I get? I get 15. And I can do the same thing over and over and over. All right. So that is how we are generating this sequence or this pattern. We just pick this first number, which is 3, and then we keep on adding 2 and adding 2 and adding 2 till the doomsday. All right. All right. So if I were to have a question says, give me the next 3 terms. The next 3 terms will be 11 and 13 and what? And 15. Okay. Okay. Now, let's say somebody says to me now, let us find the nth term. Okay. Let's say they are saying find the nth term. How would I do that? Find the nth term. How would I find the nth term? Now, what is the nth term? Now, when you look at this sequence, we said we start from 3 and then we keep on adding 2 and adding 2 and adding 2 and so on and so forth, right? And then, so there is an equation of some sort that can actually keep on producing these numbers for me. Okay? Now, that producer, that equation, now that is what we are referring to as the nth term. All right? And then that is Tn. Call them Tn. Now, how do we find Tn? Okay, so we will go back to our sequence, and then we will then identify that we have the first term that started all of this thing. Okay, so which is T1, which is this one in this particular case, and then we then give it a name, a symbol, and then we call this one A. So A is equal to T1, so or T1 is equal to A. Okay, so we take A, we take A and then we assign it to a first term. Okay, and then when we look at the consecutive terms, we actually did find that you just keep on adding 2. So basically what we're going to introduce secondly is something called a common difference, the difference between consecutive terms. Okay, so we call this D. And then what is D? It's a common difference. Okay, so we said A is a first term, and then we've got D, which is a common difference. Now, how do you find a common difference? What you simply do is you just take D is equal to T. For example, you can say it's T2 minus T1, or you can say T3 minus T2, and so on and so on. Any terms that you can pick, they will give you the first, the common difference, which is the same, because you can notice there that you keep on adding the same numbers in order to get this. All right. So in this particular case, when you have D, our D is what? Is T2, which is what? Which is 5 minus 3, which is equal to 2. So you've got our A, that is what? That is 3. And then you've got D, that is what? That is 2. Okay? So, now, let's uncheck personalities. If you have a sequence or a pattern that has a common difference, or that has the difference between any two consecutive terms being the same, then you call that kind of pattern a linear pattern, or an arithmetic sequence. Okay, so now when you've got a linear pattern, there is an equation that drives each and every linear pattern that you can ever come across. And then what is that equation? That equation is Tn, which is equal to what? Which is equal to A plus n minus 1, and then they are in bracket, and multiplied by D. Okay, so basically, ladies and gentlemen, when you are talking about a linear pattern, you are talking about a pattern that is in the form of Tn is equal to A plus n minus 1D, where when you are talking about A, you are talking about at the first term, and then D is the common difference. All right, so you already got A here, and then you've got D, and then so now if you want to find the end term of this sequence particularly, therefore you will then say okay, so we know that it's supposed to be Tn is equal to A plus n minus 1 D. All right, so in a place of A, what do you put? You put 3. In a place of D, what do you put? You put 2. Okay, so plus n minus 1, and then in a place of D you put 2. And then simplify. When you simplify, you will get 3 plus 2 times n is going to be 2n, and then 2 times minus 1 is going to be minus 2, and then the 2, and then 3 minus 2 is equal to 1. So your general equation, or your end term is going to be Tn is equal to 2n plus 1. Where do we get 1 from? Is 3 minus 2. Okay, so this, ladies and gentlemen, personalities is the generator of this sequence. Okay, this is a generator of the sequence. Now, is this true? Does this generate this sequence? Okay, now how are we going to check? So because this is T1, what we're going to do, we're going to put 1 here. Now when we put 1 here, it must generate 3. If it does not generate 3, then it means it's wrong. Okay, now let's check. So T1 is equal to 2, and in the place of n you have 1. Remember, where there was n you put 1. So you've got 2, 1, and then plus, and then 2 times 1 is 2, plus 1. So 2 times 1 is 2, plus 1 is 3. So yes, it does generate the first one. Now let's check T2. 2 times 2 is what? Is 4, plus 1 is 5, which is this one. Can you see? So it does generate the second one. Let's look at the third one. 2 times 3 is 6, plus 1 it's 7. Can you see? And so on and so on and so on. Now, because of this, we can have confidence in the fact that this is an equation that generates these particular sequences. Do you understand? Right. So this is the equation that generates these particular sequences. Okay. Now, so we've got our Tn and now we are sorted. But let's go further than this. Let's say to ourselves now, for some reasons, okay, now we know we've got 3, 5, 7, and so on and so on. Let's say somebody says, okay, what is the 20th term of this sequence? Okay, find the 20th term. Find the 20th term. So how do you go about doing that? Find 20th term. Guys, that means that n is equal to what? Is equal to 20. So we're going to go back because we already know the equation that generates this sequence. We're just going to say Tn is T20 is equal to what? Is equal to 2 times 20, right? And then plus 1. So 20 times 2 times 20 is 40, and then 40 plus 1 is 41. All right. So that means that if we can keep on adding 2 and adding 2 and adding 2 here, when we get to the 20th term, we'll then find what? We'll then find 40, 40, 41. Does make sense? Right. And then let's say, let's take a personal analysis from here. They just decide to give us what? Say, they just decide to give us a term. Let's say they say 201. And then they say to us, find what? The term whose value is 201. So how do we go about and find this one? Okay, we already have our generating sequence. Okay, now, and then it's this one. We've got an equation that generates our sequence, but now we are being told that there is a number which is 201. So basically, in this case, that means that Tn is equal to 201, but now our n is what we do not know. We do not know which term gave us 201. So how do we then find this one out? We go back to our equation, and then what we do is we then say, okay, we then say 201 is equal to what? Is equal to, and then we've got 2, we do not know what our n is, and then plus 1. Okay, and then we take, can you see now this looks like a normal solve for x equation. So we take this one to this side and it becomes 200. So we've got 200 is equal to 2n, and then we divide by 2, we divide by 2, this cancel this, and then n is equal to 100. N is equal to 100. So what is the term whose value is 201? The value whose the term whose value is 201 is what? Is the term where n is 100. So the which term is that? Is T100. Okay? Wonderful. All right. So that is the theory. Now let's just go into practice and then see what we can actually end up with. Right. Okay. No, let's not start with this one. Let's start with this one. All right. So say we've got this pattern, and then they say write the next 3 terms. how do you find the next term of this equation? Okay, we look at this pattern. Okay, it's 3 and then 11 and then 11. So okay, 3 and 11. If to get from 3 to 11, what do we do? So let's just do this. Okay, let's start with a first term. Let's say our a, we know that our a is a first term, is equal to what? Is equal to 3. Okay, and then our d, let's pick any two terms. Okay, our d is what? Let's just do this. We'll say, okay, 3 and then 11 and then 19 and then 27. So we'll say 11 minus 3. What do we get? 11 minus 3, we get 8. 19 minus 11, we get 8. 27 minus 11, what do we get? We get 8. Oh, so this has a common difference. All right, so it has a common difference, which is d. What is our d? Our d is 8. So if it has a common difference, we know that then it means that we have a linear pattern. Ladies and gentlemen, personalities, there are many patterns, but when there is a common difference, it's a linear pattern or it is an arithmetic sequence. Okay, so now, because to get to the next term, you keep on adding 8. So basically, when they say write the next 3 terms in question number 1 here, so you will say, okay, the next 3 terms from 27 plus 8. What is 27 plus 8 is 35. So the next one is 35. And 35 plus 8, what do you get? You get 43. And then 43 plus 8, what do you get? You get 51. That's it. You've got the next 3 terms. By simply recognizing what are the differences between the consecutive terms. And that's it. So question number 1 is done. Now question number 2, write the nth term. What is the nth term? The nth term is a general equation. Okay, so in this particular case, we know we've got an arithmetic sequence or a linear pattern. How do we know that? We know that because when we were looking at the differences between these terms, the consecutive terms here, it turned out that the differences are exactly the same. So because of that, we've got a linear pattern or an arithmetic sequence. So we already have a, which is 3, and d, which is 8. So in number 2, our Tn, as we know, is nothing other than a plus, you must know the sequence, guys, and n minus 1, d, and then our a is what? Our a is 3, and then plus n minus 1, and our d is what? Is 8. Okay, and then you've got 3, 8 times n is going to be 8n, and then 8 times minus 1 is going to be minus 8. So 3 minus 8, that is going to be nothing other than 3 minus 8 is minus 5. So we're going to have 8n minus 5, our Tn. Okay, question number 2 is done. We've got the nth term, which is an equation that generates all the terms of this sequence. Guys, before we can even continue, let's test this one first, whether it does work. Does it really give us what we are looking for? Okay, so let's test with the first one. T1, so 8 times 1 is 8. 8 minus 5 is 3, which is exactly this. Our first term is fine. Let's look at the second one just for argument's sake. T2, 2 times 8 is 16. 16 minus 5 is 11, which is exactly this. That means that this general equation, or this nth term, or the general term, they can call it all of those kind of things, it is fine. Okay. And then number 3 determines the 200 term. Oh, okay. So they say 200 what? Term. Okay. So what does this mean? That means that our n is equal to 200, and then we must find Tn that associates with this. We need to find T200. So T200 is equal to unknown. Okay, so how do we find T200? T200 is nothing other than what? We've already got the equation, so it's going to be 8 and then 200 and then minus 5. Okay, so what is 8 times 200? It's 200, it's 400, it's 600, it's 800. And then what? And 1000, 1200, 1400, 1600. So it's 1600. 1600 minus 5 is going to be 1595. So the 200th term here is what? Let's write it down. Therefore, the 200th term is what? Is 1595. Okay, wonderful. And then they say number 4, which term has a value of 179? So number 4, as we saw earlier, we've got Tn, which is 179, but the n that comes with it, we do not know it. That's exactly what we want to find. So how are we going to find it? We're going to take our nth term, our general equation for this sequence, and then we're going to say Tn is equal to nothing other than 8n minus 5. And then our Tn, we already know it's 179, ne? Yes, 179, which is equal to 8n minus 5. So you take this 5 to this side. So 179 minus 5, it's 170. It's 174, right? So you've got 174, which is equal to 8n. So 174 over 8n. So let's say, so we divide by 8 both sides. So 174 divided by 8. What do we then get? What do you get? All right. It seems as if there's a mistake that we did here. Can you see? Okay. When you did this 5 is minus. Can you see? There is minus 5. So when you take this 5 to the side, it must be plus. So it can't be 174. Okay. So the teacher is talking nonsense. Okay. You can't say the teacher is talking nonsense. Okay. So 179 plus 5. 179 plus 5 is 184. So this is 184. Can you see that? Right? And then so now, when you say 184 divided by 80, what do you get? You then get what? You then get 20, then get 23. So n is equal to 23. Okay, so now let's go back and answer this question. The term that has a value of 179 is, I can't write everything, but I'm supposed to write, you must write everything. Okay, so that term is what? Is T23. T23 has a value of 179. All right. Do you understand? Okay, wonderful. Let us take the last one. Right. Okay, guys, let's look at this one. I want you to notice about this one. Can you see? Can you see? This pattern has negative numbers. Negative 11, minus 8, and so on and so forth. Okay? So they need to find the next three patterns. So how do we find the next three patterns? We just look at how things go. How we go from one to another. Okay? So let's get this party going. So in this particular case, we've got minus 11, right? And then we've got minus 8, and then we've got minus 5, and then we've got minus 2. Okay? So when you look at the difference between minus 8 minus 11. Okay, let's look at. So minus 8 minus 11, what do you get? Let's just do it on the side. D is equal to minus 8 minus 11. So that means that we've got minus 8 plus 11. So which is same as 11 minus 8. What is 11 minus 8? 11 minus 8 is nothing other than 3. Can you see that? Okay, so the difference between this one and this one is 3. Okay. Now minus 5 minus 8. You also get what? You also get 3. Okay. Here you also get 3. You can check it for yourself. Okay. So that means that from here, from the first one, you just added 3 and then you go to this one. And then you added 3 and then you go to this one. So minus 11 plus 3 is minus 8. Minus 8 plus 3 is minus 5, and so on and so on. Okay. So now if you want to get to the next three terms, you must just keep on adding 3 here. Okay. So answer for question 1. When they say find the next three terms, in question 1, the next three terms, so minus 2 plus 3 is going to be what? It's going to be 1. And then minus 2 plus 3, sorry, and then 1 plus 3 is going to be 4. And then 4 plus 3 is going to be 7. And that's it. Alright? So I just want to make an emphatic point. Ladies and gentlemen, you can see that this is a sequence. It has negative numbers. Ladies and gentlemen, the sequence can have negative numbers. It can have positive numbers. It can have 0 as well. It does not matter. Okay? And including these terms like the A and B and C's, the A and B of the arithmetic sequence, it can be a negative number or a positive number. It does not really matter. Okay? Now, ladies and gentlemen, personalities, the difference between this is the same as the difference between this. That means we've got a common difference. Common difference. So if we have a common difference, which is D, it means we've got what? We've got a linear pattern, or what? Or an what? Arithmetic sequence. Okay. So in number 2, when they say we must find a general term, we know that we are looking for a general pattern of a linear pattern, because we have already identified the difference being common. So if the difference is common, we know. Okay, so we've got A, which is the first term, which is what? Which is minus 11. And then we've got what? We've got D, which is 3. Okay, from here. So the equation is Cn, which is equal to what? Which is equal to A plus n minus 1 D. And then in a place of A, we've got what? We've got minus 11. And then plus, and then n minus 1. And then in the place of D, we've got 3. When you simplify this thing, it's going to be minus 11. 3 times n is going to be plus 3n. And then 3 times minus 1 is going to be what? It's going to be minus 3. Okay, so minus 11 minus 3 is going to be minus 14. So our Tn is nothing other than what? Other than 3n minus 14. Okay, so this is basically what we got. And guys, don't forget this one. Every time when they say find the nth term, check it first before you go to the next one, because all of this question and this question depends on the question here. So if the question here is wrong, then all of these things gonna be wrong and you're gonna lose marks. Okay, and I don't want you to lose marks. Okay, so how do you then look at it? You say, okay, in question 3, okay, I've got, okay, let's go, before we even answer question 3, let's test it. T1 is minus 11, so let's put 1 here. 3 times 1 is 3. 3 minus 14 is minus 11, so it does produce this. You can check the next one and the next one and so on. Right, it does work. Does that make sense? Okay, so it does work, so I can then use it in the next one. So now they say here they want 163rd term. So what is that? That means they're looking for T163. So how do I find T163? No problem. T163 is equal to, okay, is equal to 3 and then 163 minus 14. Okay, too lazy to count this. 3 times 163, what is it? 3 times, you can just put this thing in the calculator. 3 times 163 minus 14. Then you get what? Get 475. So your answer is 475. Right? Right. Okay. Now, let's continue. The next one is, which term has a value of 178? Which term has a value of 178? So in number 4, it means that we've got a number. So Tn is equal to 178. But now, we do not know what is the n that goes with it. So how do we find that one out? We say 178 is equal to 3n minus 14, and then we say 178, we take this to this side again, so 178 plus 14, let me put in a calculator now, so that I won't do what I did earlier. It's 188, so we've got 188 is equal to 3n. So this 188 divided by 3, what do we get? Let's check this one very well. Okay, let's check. It's 178 plus 14. It's 192. I do not know where this 188 comes from. 192. Can you see that? It's 192. Now 192 divided by 3. Then you get 64. And is equal to 64. Can you see that? Therefore, the value the term that has a value of 178 is C what? C64. Okay? Because at the end of everything, we must always go back to our original question and be able to answer it. Okay, ladies and gentlemen, personalities, these are sequences and series. Now, we are going to continue with this concept. So I do suggest that if you want to get some of this work, you can then make sure that you subscribe to this channel so that when I post more of this work, you can be able to get it as well. All right? I do not know when you're going to watch this thing. Maybe you've already by the time you are watching this, I've already put the next video, so you can just go ahead in the channel and check it out and see what it is. So ladies and gentlemen, personalities, this is how you handle arithmetic sequence or linear patterns. Ladies and gentlemen, personalities, this is for paper 1 and paper. So it's for paper 1. Even in grade 8 you start getting these kinds of questions. Grade 8, grade 9, grade 10, but grade 12 as well, there are questions like this is gonna get, mostly in grade 11 and grade 12, but all other grades as well, you do find this question. So this is for everyone. All right, so ladies and gentlemen, personalities, this is Mqondisi Maxaba from Thembela Maths Club. If you haven't subscribed, please subscribe and click the notification button so that every time when I load a video you will get it. But thank you very much for tuning in, and have a lovely day, and goodbye. And if you've got any questions or any comment, please do not hesitate to put it in the comment section below. Thank you very much.